Hello guys, so we will be just targeting Gate 2022 and I'll be just following this Geeks for Geeks website where they have actually given a good preparation guide which we can follow for the preparation of our exam, and I have just converted those algorithm section given there into an Excel sheet, and we'll just start every topic, learning and understanding those. So let's get started. So here basically we have to like why this analysis of algorithm is required and why to do it. So basically, as you know, that performance matters, as you can see on the Netflix, Amazon or Flipkart website, that they have a huge customer base, and if their algorithm does not have a performance uh, like good performance, then they will suffer a lot. So that's why it's required, and for analyzing any two algorithm we can say that just that it might we can just run those two algorithm and on a computer and just see that which one takes lesser amount of time. But this will be having two downfalls, which are that it might be possible that some inputs for some inputs first algorithm will perform better than the second, and for some other inputs second will perform better than the first. And it also might be possible that for some inputs the first algorithm will perform better on a machine, and for the same inputs it might not work that good on the other machine. So, and the same is the case with second algorithm. So to overcome this, we actually have asymptotic analysis where we actually evaluate based on the input size and do not measure based on the actual running time of the algorithm. So basically, let's have an example where we have a searching problem, and we have linear search as an algorithm and binary search. So the order is logarithmic for the binary search, and the order of growth is linear for the linear search, that is order of n for linear search and order of log n for binary search. So let's say uh, two computers are there, A and B. A is much faster than B, and we just implement linear search on the faster computer and binary search on the slower computer. Let's say we make A 5000 times more powerful than B, and we will just represent those with these constants 0 0.2 and 1000 to so basically, we can say that for small inputs 0 point like A will be giving much faster results and B will be taking very long time, so which you can see with this table here. So for input size of 10, that is we have 10 array, like 10 sized array, so the algorithm A will take only 2 seconds, and for B it will be taking 1 hour. And if we have a 10 to the power 9 input sized array, then it will take 6.3 years to linear search an element in that, and only 8.3 hours to binary search in that array. So does this analysis actually work? uh, it depends. So basically, let's say we have two algorithms that have 1000 n log n and 2 n log n time complexity respectively, and as we are doing asymptotic analysis, so we do not consider those constants. So basically they both are having n log n order, of growth. So we cannot judge like which one is better, because we are ignoring the constant. Hence uh, it always depends upon the situation. Like if we have an input size, like let's say in this above linear algorithm, if we perform on A, and if we never give an input large enough, like this 10 to the power 9 or 10 to the power 6, then it will always give us a better result. So this might happen that we only need this kind of small inputs. So in that case, linear search might be a best option in this case. So basically it depends on what we want and which algorithm we should use. And this topic ends here, and we will mm, be doing the second set in the next video. So thank you guys.